Let's talk about the largest comet ever observed, UN-271. It was active way out there, 16 astronomical units from the Sun, where the sunlight is just a whisper. In comparison, the interstellar object 3I Atlas, at its closest approach, was bathing in a solar hurricane, receiving 140 times more energy. You'd think that would explain its features, but it doesn't. Simulations show that at that distance, any jets from an object like UN-271 would just blur and fragment. The million-kilometer aerostraight jets seen on 3I Atlas simply don't appear in these models. And what about its rotation? 3-1 Atlas spins every 16 hours. Standard models predict this rapid rotation should chop its jets into segments or smear them into a curve. Yet, they remained perfectly straight, as if something was actively holding them steady against both rotation and the solar wind. The physics just don't add up. So, how does the scientific community react to something so strange? Overwhelmingly, they reach for the familiar. About 95% of professionals classify Atlas as a natural comet, even as the list of unexplained features grows. This isn't a conspiracy, it's cultural inertia. A tendency to trust established models, especially when the alternative is a potential technosignature. When anomalies stack up, the first impulse is to find a natural patch, to make the data fit the expected story. Even when the physics don't line up, the gravitational pull of consensus is strong. But leading authorities like Dr. David Jewett are calling for a closer look. He points out that the chemistry and polarization of 3I Atlas are genuinely unusual, outliers compared to any known comet. He emphasizes that while we should exhaust all natural explanations, the evidence is strong enough to demand a full, independent reanalysis of all the data. The role of science is to follow the data, even when it leads to uncomfortable places. These anomalies deserve scrutiny, not dismissal. So the next step is clear. Every major dataset on 3I Atlas must be made public. The raw images, the spectral data, the polarization curves, all of it. There's no technical or financial barrier to releasing this information immediately. The call is simple: publish the data and let outside teams run the numbers. With over $100 million invested globally in technosignature research since 2019, what we dismiss today could be tomorrow's biggest breakthrough or our greatest blind spot. The cosmos doesn't care about our assumptions. It rewards those willing to question the script. So, what if the real anomaly is our refusal to look closer? Let me know your thoughts in the comments below, and don't forget to follow for more.